Question 12 of the photoelectric effect worksheet. So, in an experiment, light of different frequencies is shone onto two photocells, one with a cesium cathode, one with a sodium cathode. So we got two different metals. Then, the sketch graph of frequency versus kinetic energy of the emitted electrons is shown below. Brilliant. First question, define the term threshold frequency. Well, that's the minimum frequency of light needed to eject electrons from the surface of a metal. Okay, great. Then they say which photocell for the same frequency in light will emit electrons of a higher kinetic energy. Well, when you look at this, okay, cesium has a much lower threshold frequency. That means the electrons will be getting kinetic energy a lot faster than the sodium does. So that means this is the cesium, spell it right. Cesium. Does feel funny with the CA. Then they say name the energy value shown as A. Now this is an interesting thing for you. So when our photon, okay, has a frequency of 0, which we know can't happen, there's a negative value to the energy of the electrons. In other words, before the electrons can even think about moving, they've got to gain all of this energy. Once they've got this amount of energy, we've got the work function. We've given them enough energy to leave. So this energy is the work function. Okay? Then they say write down the quantity represented by the gradient of the graph. Well, in this case, it's Planck's constant. Alright, and that's why the gradient of both graphs are the same. Then they say, for a certain frequency of light, the maximum kinetic energy of the photon from the sodium cathode is 2,03 times 10 to the minus 19. That's EK max. Alright? They want to know the wavelength of the wave use. As soon as we're looking at EK max, we know we're going to use E equals WO plus EK max. We want to know the wavelength, so we're going to do HC over lambda. We're going to use HFO because I know the threshold frequency from the graph, and they've given me EK max. So this becomes 6,63 times 10 to the minus 34. C is 3 times 10 to the 8. I want to solve for lambda. 6,63 times 10 to the minus 34. When we look at the graph, the threshold frequency for sodium is 5. Oopsie, maybe I should do it so you can see that. 5,31 times 10 to the 14. Okay, 5,31 times 10 to the 14. We're going to add that to the 2 times 10 to the minus 19. I'm going to leave the maths all to you. Hopefully you can manage. Okay, and what you'll get is the wavelength is 3,58 times 10 to the minus 7 meters, and it's small. It's what I expected. Times 10 to the minus 7 is well within the range of what we're looking for. Then, what influence will the following changes on the incident light have on the maximum kinetic energy of the photoelectrons emitted? And we're either going to use increase, decrease, or the same stays the same. An increase, that should say, in the wavelength. Now remember, Alright, so, and we need to explain it. So I'm not going to write the answer just yet. If wavelength increases, okay, frequency decreases, okay, because C equals F lambda. Therefore, photons have less energy. What does that mean? So what happens to the maximum kinetic energy? It's going to decrease. Okay? So the maximum kinetic energy, there we go. Oh, look again. Will decrease. Okay? Then if the intensity of light increases, well, intensity of light's got nothing to do with the energy, the photons. So here it stays the same. Why? Because the intensity of light has no influence on the energy of the photons. Okay. Done.